think a very important question is, what is water quality? And I think a lot of people don't know what they're asking when they say, what's the water quality like in the river flowing through your farm? And we need to be specific and get into those details if we want to try and improve the water quality, national water quality standards that are being reported by the EPA.
It's great to be back with another Environment Edge podcast, and you're very welcome to the show. This episode is part one of a two-part series, so make sure to tune in next time also.
Teagasc Agricultural Catchment Specialist Eddie Burgess joins us to discuss the challenges around water quality in Ireland currently and gives his outlook for the future in this area.
I'm Cathal Summers.
And I'm Deirdre Glenn.
Your Teagasc Sustainability Advisors, and we're back for another Environment Edge podcast, number 89, and here we go.
Eddie, you're very welcome back to the show. You were so good the last time that we've got you back. Can you give us a quick recap on what goes on in the ACP, or the Agricultural Catchments Programme?
So the Agricultural Catchments Programme we're funded by the Department of Agriculture. It's been implemented by Teagasc, and we're monitoring the influence of measures that farmers are asked to do under the Nitrates Action Programme at a very high resolution. And what I mean by a very high resolution is we take samples very frequently, every 10 minutes in some cases, monthly in others. And we also do the catchment areas that we work in. There's 6 of them. They're small, but we also monitor throughout the whole catchment. We don't just take catchment samples and monitor water at the outlet where water in the river is leaving the catchment. We monitor groundwater, we monitor soil water, we monitor the soils at every 2 hectares. And we do that continuously and have been doing that continuously for the last 15 years. So we're building up a data set over a long period of time now. And it gives us a very good understanding of the processes that influence water quality in 6 different agricultural settings that were selected to represent different soil types and mainstream agricultural production systems in Ireland.
Eddie, you mentioned farmers there. Was there good buy-in by the farmers from the initiation of the whole programme? I assume it was voluntary to start with.
No, it was and still is voluntary. And there is good buy-in, but initially at the start, you can understand landowners and farmers were apprehensive and, I'd say, cautious, because we had basically went up and knocked on the door, introduced ourselves and said that we're working in a water quality monitoring programme, trying to evaluate the nitrates directive. And any farmers listening here now, try and put yourself in those shoes. Eddie comes up and knocks on your door and says you're doing that. Would you be jumping up and down with delight? I doubt it. Although in the last 15 years, and particularly in the last 5 years, the level of interest in water quality has changed. And I will say that more and more now I get asked by groups of farmers, how can we monitor water quality in our locality, and what should we be doing to get an understanding ourselves? So there is an increasing interest in water quality. There's a long way to go. I'm very conscious that I work in this area. Like I'm talking to you today. You're working in the ASAP program, and we a lot of people say we all work in our own little bubbles. If I'm standing at the side of a rugby pitch at Saturday afternoon and talking to farmers beside me, they're not going to come up and start talking to me about what can I do to monitor water quality.
No, that's true.
Yeah. So we need to be realistic, very realistic in our expectations of how engaged people are. Some sectors of the agricultural industry are naturally and understandably, and we all know what I'm talking about, much more interested because they're being directly impacted by changes in regulations that are influenced by water quality, and others are not.
The advisory area then, the farmers within that area would have had advisors. They would have had their dairy or their beef or their tillage advisors. So you would have had to connect in with them as well. So there would have been a relationship and a trust built up prior to you actually going into the area too.
I'd say we wouldn't have been able to get established in any of the 6 catchment areas without the existing Teagasc advisory relationship that was built up in each of them. They were key, I'm going back, we're talking about advisors that were working 20 years ago in localities and had built up a relationship over a career, giving us an introduction and a foot in the door. And if we didn't have that, we wouldn't be in a good place now. And we really cannot understate the importance of the core advisory impact of the advisor who has built up a relationship with farmers and is going in and working with them on everything from succession to tax to production to environmental issues. The impact that the core advisory service has, be it Teagasc or be it a private advisor, is not to be understated. And I always have believed that, and I know we have in Teagasc now, we have the ACP advisors, we have ASSIP advisors, we have climate change advisors working on a targeted focus, but the level of contact and relationship that those programs build up with farmers is not the same as what a core production advisor has. And if we lose that, we're not in a good spot. I cannot emphasize that enough. But that was clear from the outset of the ACP program. We wouldn't have been able to get established without that relationship that had been built up.
Yeah, but you made a good point there a minute ago. On the rugby pitch on a Saturday, and you're talking about water quality. The very same for an advisor. If an advisor rolls into the yard and says, "Come on, let's go down and talk about water quality," it doesn't float anyone's boat. Like you have to balance all sustainability, like you said, the production side and the associated sustainability side. So I think you're bang on there, and the advisor has a kind of a finger in every pie, which is huge help. They can bring the research right down to farm level. And something, if the farmer disagrees with them, they can hammer it out in the discussion group and come up with a good solution. So I think that's why the relationship works so well. But
Yeah.
Looking back on the ACP, you're around a long time now, and I think we're starting to talk a lot about catchments. What is a catchment for people that are not really sure or maybe afraid to ask the question?
Yeah, no, there's no such thing as a stupid question. There is people that don't listen to the answers and might ask it a second time, but there's no such thing as a stupid question. And I'd like to follow on, actually, and I will come back to answering your question, what is a catchment? But I think a very important question is, what is water quality?
Yep.
And I think a lot of people don't know what they're asking when they say, what's the water quality like in the river flowing through your farm? And we need to be specific and get into those details if we want to try and improve the water quality, national water quality standards that are being reported by the EPA. But going back to your question, what is a catchment? A catchment, another name for a catchment is a watershed. A catchment is like a bowl. It's defined by the highest point around the edge, and all the water leaving a catchment comes from the rainfall that falls within that bowl shape or that catchment area, if you like. And it either leaves via a stream flowing out of the catchment, it leaves via evapotranspiration coming out of leaves of plants that are growing in the catchment, or it could leave via groundwater flowing out underneath somewhere that we don't know about.
Yeah, so there's lots of routes, and I think that's important, and it goes back to what you're saying about the water quality in my local area, and we'll touch off that in a few minutes actually. But I just wanted to ask you something. We're in the close season now, and myself and Deirdre, and I'm sure you as well, we're constantly out with groups of farmers, and there's always an argument. I think today we're about 17 degrees or something. It's quite warm today, and I know it's quite wet as well, but farmers are telling us the grass is growing. And if the weather stays like this as well, there'll be plenty of growth. Why can't we spread slurry and during the winter time when the grass is growing and the weather is mild? And you have some interesting results over the years in the close period that I often tell farmers about. Can you tell me a little bit about them?
Yeah. So again, coming back to what you're asking, what is water quality? We measure the concentration of nutrients in the water leaving the catchment. We also measure the volume of water. And when you multiply the amount of water how many cubic meters of water left over a given time period by the concentration at the same time, we can calculate how many kilograms or how many tons of sediment, of nitrogen, or of phosphorus left the catchment. And you can divide that into interesting time periods. For example, Hurricane Charlie, heavy rainfall came after it. The river went into flood and it dropped back down to base flow. We can calculate the total nutrient loss that arised as a result of that heavy rainfall from that event. Or we can look at the annual amount of nutrient that left and divide it by the area of the catchment and calculate an average amount of nitrogen and phosphorus per hectare that leaves from a catchment. Or we can look at the closed period of catchment, and I think that's what you were alluding to in your question, Cathal. If we look at the closed period, which is what was typically 25% of the year in the southeast, we can measure the total amount of nitrogen and the total amount of phosphorus that left in the water and compare it to the annual amount that leaves. And typically, year in, year out, between 45 and 50% of the annual phosphorus that leaves the catchment does so during that closed period, which is only 25% of the year. And the same for nitrogen.
But if it's a closed period, there wouldn't be any application of nutrient or organic or inorganic nitrogen on the soil or on the grass or whatever is there at that time.
That's correct, Deirdre. And it's very important to be aware. I'm not saying when that nutrient was either applied or was made available to be lost. Maybe it wasn't applied at all. It could have been in the soil. It could have been in the riverbed. It may well not have come from an application method, but the soil conditions during the closed period are usually if we say at capacity, the soils are wet, even if there hasn't been rainfall. The day length is shorter, and there isn't the same evapotranspiration rates. A daily, like typically, it rains around 1 meter in Ireland, and half of that water leaves in the river, and the other half goes somewhere else. The other place it typically goes is up into the air through evapotranspiration, and evapotranspiration rates don't fluctuate much during the year like rainfall does. Like you can have a very wet summer, but the evapotranspiration rates are always higher when the daylight length is longer. And they would typically go from around 4 millimeters a day in June, May, June, July, to we're now in the middle of October, and it'll be closer to 0.5 millimeter. And today it's dull and drizzling here, it'll be 0. There'll be no evapotranspiration taken. It's not raining with me today. It's drizzling, but the amount of rainfall will be nil, but there's no drying taking place. I didn't hang any washing out in the line today.
Is there any difference then between the type of soils? So you've got your heavy clay soils and your lighter soils within the area of the losses within the catchments?
Massive difference. Naturally, farm practice and farming intensity has an influence on the amount of nutrient that's available to be lost. But how much actually gets lost is more often than not, decided by the weather and the soil type, and the influence of the weather and the soil type will override the influence of farming intensity at the outset. And typically, if you have a high clay content soil, a heavy soil, they'll get wetter quicker, and most of the water ending up in the stream gets there via an overland flow pathway because the soils are wet. And also, if soils are wet, the bacteria in the soil are anaerobic type bacteria, which live on nitrate as a source of oxygen. So they're denitrifying bacteria, and they mitigate nitrate loss if there's a source of carbon and temperatures are warm. In contrast to that, on a free draining soil type, When it rains, most of the water ending up in the stream gets into it by groundwater-fed springs. And the water percolates through the soil before it ends up in the river. And by doing that, any phosphorus that is being carried by that water is bound by the clay in the soil. And by the time the spring feeds into the stream, the amount of phosphorus that's left is very, very small. But that's exactly how nitrate is carried. So there's contrasts between nitrate and phosphorus. And that's why our free draining catchments typically have high nitrate levels in them. And that's not a reflection of the overall nitrogen application rate. It's not a reflection of the nitrogen use efficiency. It's a reflection of the soil type. And our heavier draining, heavy clay soils will typically have higher phosphorus levels and lower nitrate levels. And ironically, many of those have lower phosphorus application rates, have lower soil P levels, and even have higher nitrogen application rates going on to them.
I think farmers can get their head around phosphorus and sediment loss because it's visual and they can see brown water going down the field and into a drain or whatever. I think when I go into farms, I find it harder to get the nitrate loss advice piece across because I think we had a discussion before. You can shed more light, but you could have a river going by your farm and it could look in good condition. It could be deemed as good condition by the EPA, but you could be losing a lot of nitrate on your farm.
Yeah.
Is that correct?
Yeah, and even more extreme. I heard one of your colleagues from Kildare in the ASAP program saying that actually the type of farm that is most problematic for nitrate probably doesn't have a watercourse on it at all, because the free draining soil type, when it rains, the water percolates down through the soil and there isn't streams or ditches on it. And because the soil is so free draining, that's where nitrate is more than likely going to be coming from.
And that could be getting deposited down the river a number of miles away, and then there's a difference then, is there, between say shallow groundwater and deep groundwater, or where does the nitrogen end up?
Yeah. You're coming at me with a lot there, Carl. Well, I suppose before I go to the shallow and deep groundwater, I'm going back to what is water quality, and we take a sample every 10 minutes and we're measuring the nutrient in it, and I'd say we're very good detailed understanding of the nutrient load in the water, but really what water quality is, and I asked a bunch of students from Cork this time last year, and I got the best answer ever from one of the ag students. So water quality is a measure of the conditions for supporting life at that point. And that's at the water quality at that particular location. And nutrients can affect that, sediment can affect it. Your nutrients and sediment could be pristine, but there could be a problem with a pesticide getting in and it could affect that. The shape of the river can affect it. That's hydromorphology, and that's another difficult aspect to try and understand. But not only is water quality a measure of the ability to support life at that point, it's also a measure of what is being delivered by the watercourse to a point further downstream that could have an impact on the water quality there, downstream from where you are. So I think there's two key aspects to water quality. One is the conditions at the point where you're taking the sample or looking at it, be that in a stream or in a lake. And one is further downstream from there. What has been delivered to the lake downstream or been delivered to an estuary downstream from there. And if we're looking at what's been delivered, we're more interested in the total amount, how many kilograms of nitrogen or how many tons of sediment is being transported, or how many kilograms of phosphorus is getting into the lake.
So there you have it. Tune in next time to hear more interesting chats and discussion.
Myself and Deirdre will be back in 2 weeks' time, but do give us a review on Apple, Spotify, or wherever you get your podcasts. Thanks for listening to the Environment Edge podcast.